Then the molecule, as we know, the in covalent bond can be a polar covalent bond or it can be a non-polar covalent bond. Then the molecule, a covalent molecule can be a polar covalent molecule. A polar covalent molecule means it is affected by electric field. A non-polar covalent molecule is not affected by electric field. So a covalent molecule can be a covalent molecule can be a polar covalent molecule. What is the meaning of polar covalent molecule? Polar covalent molecule means it is affected by electric field. Or it can be a non-polar covalent molecule. If it's a non-polar covalent molecule, means it is not affected by electric field. Like electric field does not have any effect on that molecule. Say, if we have a stream of a polar, like a covalent molecules are there which are polar. So if they're moving through electric field, so what we observe their deflection. So they're deflected in electric field. If they're deflected in electric field, we call that as a polar. This is a test to distinguish whether a molecule is a polar or a non-polar. If it is not deflected, undeflectedly it moves through the electric field. So if there is no deflection in electric field, we call that molecule as a non-polar covalent molecule. But these non-polar and polar covalent molecules, it depends on two things. Number one, it depends on whether a covalent molecule, like what is the geometry or the shape of the molecule, as well as the number of the atoms attached to the, or how many bonds are present. So example, if a molecule is polar, if there's a polar covalent bond, it will always have, it will always contain polar bonds. But if a molecule is non-polar, then it has two possibilities. If overall molecule is non-polar or it is not affected by electric field, then what are the two possibilities? It may contain non-polar bonds or it may contain polar bonds. So example, if I say hydrogen chloride, HCl, so hydrogen chloride, partial negative, partial positive. So if there is an unequal distribution of the bond in the molecule and the charge still appear on the molecule, we call this term as a dipole moment, or there's a net dipole moment. So this molecule will be a polar, having a the bonds are polar. Why the bonds are polar? Because the bonds are formed between the two atoms which are having a difference in the electronegativity. So when bonds are formed between the two atoms which are having a difference in electronegativity, so bonds are polar. And what about the molecule? The molecule is also a polar because overall they are not cancelling out the effect of each other. But non-polar molecule which contain non-polar bond, like example, hydrogen. So what about the bond? The bond is non-polar. And what about the molecule? The molecule is also non-polar. But it may be a polar bond, but a molecule will be non-polar. How this can happen? Example, if carbon form a bond with chlorine, 4-chlorine. So carbon is partial positive. This chlorine try to attract. This chlorine is attracting. This chlorine is attracting. So all the 4 chlorines are attracting the electron pairs. So the resultant moment or the net resultant distribution of the electron is 0. Like, because what if I say, like example, if I have a box and I apply 5 Newton from right hand side, 5 Newton from left hand side, 5 Newton from top and 5 Newton from bottom, where this box will move? Upward, downward, right or left? Where this box will move? Or is there any movement for the box? So this box will not move because the resultant is 0. So same thing happen, like each chlorine is trying to attract the bond pair and resultant distribution is 0. So these bonds are polar, that's right, but resultant molecule is a non-polar, so this molecule will not be affected by electric field. So what we do, we check the geometry of the molecule, the type of the bond and the geometry of the molecule to identify whether it will be a polar or non-polar. Same thing, what happened, like example, if one of the chlorine is replaced by hydrogen, or if hydrogen is there or 3 hydrogens are there and 1 chlorine, partial negative positive, hydrogen electronegativity is approximately same as carbon. So what kind of molecule is this? Because the bond is polar as well as there is a resultant distribution of the charge, and due to this resultant distribution of the charge, this molecule will also be a polar covalent molecule. Another example, like carbon dioxide, CO2. So in case of carbon dioxide, oxygen partial negative, carbon partial positive. So what will happen? This molecule will be polar or non-polar? Two oxygen atoms are surrounding the carbon. So it will be a non-polar. Why it will be a non-polar? Because one oxygen is attracting the electron pair towards right, another oxygen is attracting towards left. So what is the resultant charge? Resultant, there will be no distribution of electron. So resultant, there is no distribution of electron. So this molecule contain a bond which are polar, but the overall molecule will be non-polar because it cancel out the effect of each other. So this is also a same example for a molecule. So what happened? A covalent molecule may be a polar covalent molecule, may be a non-polar. If it's a polar covalent molecule, it will contain a polar bond. But if it's a non-polar covalent molecule, then there are two possibilities. It may have a non-polar bond or it may have a polar bond, but these polar bonds cancel out the effect of each other. So resultant dipole moment or resultant moment or distribution of the charge is 0. In case of H2O, what happened? In H2O, it is not a linear structure. H2O is a bent or a V-shaped structure. So if this is oxygen, there are two lone pair on oxygen and two bond pairs. So this is a bent or a V-shaped structure for water. So due to this, what happened? Oxygen is partial negative, hydrogen positive, other hydrogen. So for in case the two high, because they are not linear, it is not linear because they should, like the force by which one is attracted, the second one should be attracted with the same force in the same direction, so that they can cancel out the effect of each other. But for water, it is a bent structure. That's why the water is a polar compound. Polar compound means its bonds are polar and it is affected by the electric field. So when we pass the water or a stream of a water through the electric field, it will also deflect because it's not a linear structure, it is a bent structure or V-shaped structure. So we have a polar or a non-polar molecule. Basically, the symmetrical molecule means in which all the bonds are identical and there is no lone pair, will not be polar, even the individual bonds within the molecule are polar. Like here you can see carbon dioxide is a symmetrical molecule. Symmetrical means like same symmetry is there within the structure. And what about the bonds? Bonds are oxygen partial negative, carbon partial positive, oxygen partial negative. So the bonds are polar, but because of the symmetry, they cancel out the effect of each other. So overall molecule will be non-polar. But here chloromethane or methyl chloride is a polar molecule. Why methyl chloride is a polar molecule? Because it is not having a symmetry. 3 hydrogen and 1 chlorine is there. But tetrachloromethane is a non-polar. Why? Because it is having a symmetry. Is it clear? The polar and the non-polar molecule, the concept. Any doubt in this part? So basically, this is the same thing which I already discussed with you, how to test that whether a molecule is a polar or a non-polar. So if a jet through which a jet of a liquid is there, which is coming out from the burette, if it is deflected, it means it will be a polar. If it is not deflected, it means it will be a non-polar. Now, intermolecular forces, what are the intermolecular forces? Intermolecular forces refers to forces between the molecule. So there are different types of intermolecular forces. We have between the covalent molecules. Number one, one is known as dipole, induced dipole. or you can also say London forces or weak van der Waals forces. Many names are used for these forces. Van der Waals force you can also mention. And normally all kind of molecule, all molecular substance and noble gases have these. I will just mention the names and then I will explain each of them. Then there is dipole force or permanent dipole force we can say. Then the third one is hydrogen bond. So these are the three types of intermolecular forces which exist between the covalent molecule. Basically, London dispersion force or in this weak van der Waals force, what happened? It exists in all the molecules, and this force is directly proportional to number of electrons. Basically, what happened? If I say we have helium, a monoatomic gas, it exists in all the molecule, but because it's easy to understand in terms of monoatomic gases. So what helium contain? Helium contain 2 proton, 2 neutron, and in the first shell it contain 2 electrons. Then there's another helium atom. Helium is a monoatomic gas which is having 2 protons, 2 neutron, and 2 electrons. Now what happened? The size is same, but because the molecules are moving randomly, so they collide with each other. So the moment they collide with each other, what they cause a distribution of electron or shifting the electron density. Like, because what happened, electron is negative, like charges repel and unlike charges attract. So electrons are actually shifted, or what it appeared that nucleus is move one side, not completely to one side. Nucleus is slightly moved from the center and electrons are shifted towards one side. So this is a distribution is created when the molecules are colliding. So this distribution, there is an attraction between the nucleus and the electron, and this attraction within the molecule, what we call between the two atoms within the structure, what we call that as dipole induced dipole force. And dipole induced dipole force increases as the number of the electron increases. Greater number of electrons, stronger attraction. That is why higher dipole induced dipole force. So it depends on the number of the electron as well as the size or the number of electron shells. Is it clear? That first initially, like if this is one molecule, even you can take for chlorine molecule, like for a chlorine molecule is Cl2. So this is one chlorine molecule. Its bonds are polar and the molecule is also non-polar. Bonds are non-polar and the molecule is also non-polar. Then there's another chlorine molecule. But what happened when they collide with each other? They cause a distribution. As they cause a distribution, like positive charges distributed one side slightly and negative charge to other, and positive charge of one and negative to other, then this distribution will make an attraction between the positive and negative charges, and we call that as instantaneous dipoles or dipole induced dipole forces or weak van der Waals forces or London dispersion forces. Is it clear? So it is existing between the molecule and the noble gases, but do not exist in ionic compound, because ionic compound there's an electrostatic attraction. This is only for covalent compounds. Is it clear, this part? The London dispersion forces. Any doubt in this one? So if a question is like as we go down the group, like we have fluorine, chlorine, bromine, iodine. So if a question is as we go down the group, why the boiling point, melting point or boiling point is increasing? So the reason is there are more electrons. So the London dispersion forces or weak van der Waals forces get stronger as the number of electrons in size increases. There are more electrons, so greater distribution and attraction towards the nucleus, which cause the higher melting point or which make the melting point higher. Any doubt in this one? So if a question is, because these are the explanation which are related to the exam style question, so how you should answer. So if for example, if a question is why the iodine is solid where chlorine is gas, what is the reason for that? Because what happened as we go down the group, the number of electrons are also increasing. So it increases the number of electrons and cause a molecule increase in size of a London force. That's why iodine is solid where chlorine is gas. Same thing, why, like for if we have a homologous series means that there are certain properties for homologous series. They have same method of preparation, same general formula. Each member differ by CH2. Physical properties gradually changes. So as for example, if we have CH4, which is methane, the second member is ethane C2H6, the third member is C3H8, the fourth member is C4H10, fifth member C5H12. As we go down, like in this series, what we observe? We observe the boiling point or melting point is increasing. What is the reason why? The same reason, because look, methane, this is methane molecule. The bonds are symmetrical bond, and they, if bonds are symmetrical, identical, and there is no lone pair, then this molecule will be a non-polar molecule. Same thing, bonds are symmetric, identical, non-polar. So what kind of force is existing between the non-polar molecule? Strong. It exists between polar molecule as well, but for non-polar, that's the only force. So that's a weak van der Waals force. How many electrons are there? Carbon contains 6 electron and each hydrogen contains 1. So there are 10 electrons total in the structure and 10 electrons here. But when we draw for ethane molecule C2H6 and C2H6. So carbon 6, atomic number is 6. So there are 2. So there are 12 electrons due to carbon and 6 electrons. Hydrogen is having 1. So 6 electrons, so total 18 electron. Here also 18 electron. So as the number of the electron increases, the attraction between the molecule increases. So van der Waals force or London dispersion force will also increase. So the main factor which affects the London dispersion force is the number of electrons. The more electrons there in a molecule, so higher chance of temporary dipole form, and this make a London force stronger and more energy is needed to break them, so the boiling point will be greater. The second kind of force is known as permanent dipole or dipole-dipole force. This kind of force is existing between polar molecules. Like when the molecules are polar, example, we have hydrogen chlorides. So this is HCl. There's another HCl molecule. So two molecules are attracting each other, partial negative and positive, but and they have permanent, like it's not produced, it is permanently there. But in dipole, induced dipole, it is not produced. Like chlorine is there, another molecule of chlorine and chlorine. So there is no like the charge or the presence of the partial positive negative. But when the molecules come closer or colliding with each other, this create a distribution partial positive negative positive negative, and there is an attraction. That attraction leads to dipole induced dipole. But in dipole force or permanent dipole force, the molecules are polar. As the molecules are polar, this will cause the permanent attraction is there between the molecule, and this permanent attraction, so dipole forces are relatively stronger as compared to dipole induced dipole. But what happens as a number of electron increases, so dipole induced dipole force can also be increased. But if you have same number of electrons in the two molecule, and one is having a dipole force, another is dipole induced dipole, so in that case the dipole force is stronger. But as the number of the molecule increase, so strength of dipole induced dipole force will also increase. So if a molecule is a polar molecule means like a molecule is having unequal distribution of the electron, and there is a permanent charge appear, like if we have C double bonded with O and Cl or CH3, then C double bonded with O and CH3. So oxygen is more electronegative, partial positive, partial negative, partial. So there will be attraction between the partial negative and positive, and due to this attraction between partial negative and positive, what we call that as dipole force. There is a dipole induced dipole force. Like example, this carbon is having a uniform distribution, so they have dipole induced dipole, but that is weaker as compared to dipole force. Is it clear? So if a molecule having a same number of electrons, then dipole forces are stronger. Same number of electrons, then dipole forces are much stronger as compared to dipole induced dipole force. And it exists between the polar molecules. Any doubt in this? So van der Waals force is there, and still a dipole force will be there if it contain a permanent dipoles. Any doubt in this part? Then the last one is known as a hydrogen bond. I will explain hydrogen bond today, and then in the next class we will compare these forces and predicting the boiling point of different substances. So basically, what is a hydrogen bond? The hydrogen bond exists when hydrogen form a bond bond with more electronegative element such as nitrogen, fluorine, nitrogen, oxygen, and nitrogen. So when hydrogen is forming a bond with more electronegative elements such as fluorine, oxygen, and nitrogen, we call that as hydrogen bond. Why specifically hydrogen bond? Look, what happened, like if I say hydrogen form a bond with fluorine. So there's a bond between hydrogen and fluorine. Fluorine is, when we compare the electronegativity, fluorine is more electronegative than oxygen, and oxygen is more electronegative than nitrogen. Now, when hydrogen form a bond with fluorine, so it belongs to group 7, so they will share one electron, fluorine will share one, hydrogen share one. But fluorine is more electronegative, so what happened? That actually it appeared that the bond pair is actually completely shifted towards fluorine. So as the bond pair is completely shifted towards fluorine, so it appear that the hydrogen does not have any electron. In a molecule, it appears that hydrogen does not have any electron. Then there is another molecule of hydrogen fluoride in which the fluorine, which is more electronegative, will take almost the electron is shifted. It's like appear as a complete shifting. So it appears that hydrogen does not have any electron. So if hydrogen does not appear, hydrogen does not have any electron. So to gain the stability, what happened? The hydrogen is attracted towards the lone pair of another molecule, lone pair of electron present on the other molecule, and this bond between the hydrogen and the lone pair of electron on the other molecule, what we call this? We call this as hydrogen bond. And hydrogen bond, the bond angle is always 180. Like this is a covalent bond, this is a hydrogen bond, so bond angle will always be 180 degrees. So this only happen in 3 cases: hydrogen forming a bond with oxygen, nitrogen, and fluorine. Like example, if hydrogen is forming a bond with chlorine, then there is no hydrogen bond. Why there is no hydrogen bond? Because chlorine is more electronegative than hydrogen, but so electron shifted more towards chlorine than hydrogen, but still hydrogen have these electrons. But in case of fluorine, oxygen, or nitrogen, what it appeared? It appeared that hydrogen almost lost those electrons to fluorine. That's why the hydrogen is attracted towards the lone pair of another molecule, and this attraction is known as a hydrogen bond. And hydrogen bond is much stronger as compared to a dipole-dipole force. So when we compare the strength, the dipole-dipole forces are more than dipole induced. But if we compare hydrogen bond, the hydrogen bond is the strongest in all these three. Hydrogen bond followed by dipole force, and then followed by dipole induced dipole force. Is it clear? The idea of the hydrogen bond, what is hydrogen bond and how it is formed? So you can see here, like in ammonia, nitrogen form a bond with hydrogen, partial negative, positive, positive. So what it appeared? It appeared that this bond pair is almost shifted towards nitrogen. So if this bond pair is almost shifted toward nitrogen, this hydrogen is attracted towards the lone pair of another molecule, and the bond angle is always, for hydrogen bond, the bond angle is always 180 degrees. Is it clear that concept of the hydrogen bond? So it is always formed when oxygen, fluorine, or nitrogen forming a bond with hydrogen, and hydrogen bond occur addition to London forces. There are London forces, but hydrogen bond also exist. So alcohols, carboxylic acid, proteins, amines all have hydrogen bond, because alcohols, the oxygen is forming a bond with hydrogen. Carboxylic acid, there is a OH bond. Proteins, amide or peptide linkage, which contain nitrogen forming a bond with hydrogen. And amides also, nitrogen form a bond with hydrogen. So they have hydrogen bond. And hydrogen bond is stronger. So the molecule which are having a hydrogen bond will have much higher boiling point as compared to dipole dipole, and dipole dipole will have a higher boiling point compared to dipole induced dipole force. Is it clear, the hydrogen bond? Any doubt? Any doubt or a question related to the class today? So we discussed today the geometry or the shapes of the molecule and the force of attraction between the covalent molecule. So there are three types of forces: dipole, induced dipole force, which is existing in all the covalent compounds. Dipole, permanent dipole only exists if the molecules are polar, and hydrogen bond existing when hydrogen form a bond with oxygen, fluorine, or nitrogen.